Okay, so now we're at D is context depth. A dimensionless measure of how far into the compression process the system has traveled, or how many layers of structure have been resolved. Think of it as iterations of compression, layers of analysis, or recursion depth. It's not a physical distance, so it maps onto physical scales precisely as later chapters show. N is the alphabet size, the number of distinct symbols the system can produce. For byte system, N equals 256. For DNA, N equals 4. For the 20 canonical amino acids, N equals 20. For the 8 gluon color states, N equals 8. The theorem works for any N greater or equal to 2. 1 over N is the 1 over N is the fixed point, the entropy floor that the system asymptotes toward but never crosses. It is the irreducible coordinates of the alphabet. The minimum entropy is consistent with the system still being able to distinguish one symbol from another. Below 1 over N, information has been destroyed. Information is being destroyed. The floor is a hard constraint, not a soft guideline. 4 pi is the decay constant, characteristic depth over which entropy falls by a factor of 1 over E of the floor. It's the same 4 pi that appears in quantum field theory propagators in the fine structure constant and as a solid angle subtended by a complete sphere. It did not get placed here. It emerged from the derivation. Log of 2 divided by 4. Log of 2 and parentheses divided by 4. Is it natural log is ln? Because there's E and that's log. And then ln I think is natural log, isn't it? Can't quite remember. Is the initial entropy amplitude the value of H of D minus 1 over N at D equals 0? It sets the starting height of the decay curve above the floor. 3 constant, 0 free parameters. None of these values were chosen to make the equation fit data. Each one was derived. What it says in plain English. Every structured information system, no matter what it encodes, no matter what its alphabet is, follows the same decay law as it is compressed or analyzed more deeply. Start with a file, a DNA sequence, a price series, a fluid velocity field, sequence of primes, or a protein conformation. Mesh its information entropy. As you push deeper into the structure, compressing more aggressively, analyze at finer scales, iterating the description, the entropy drops. It drops exponentially at a rate governed by 1 divided by 4 pi. It never reaches 0. And it never reaches 0. It approaches a floor that depends only on how many symbols the system uses. That floor is 1 divided by n. It is the irreducible coordinate. It is the point at which you have extracted anything extractable, and what remains is the one piece of information that the system cannot give up, the bare fact of which symbol it is. The shape of the decay curve, exponential asymptotic to 1n, with characteristic scale 4n, is the same across all domains. Bytes and gluons, DNA and prime distributions, market prices and fluid flows. The same curve, the same constraints, one theorem. Okay, gonna stop there.